Look at the speed of modern manufacturing. We turn abstract geometry into physical reality at a staggering pace. It's easy to look at these massive logistical achievements and assume the engineers behind them spend their days in a state of unencumbered creativity, effortlessly inventing the future. But the historical reality of engineering looks a lot more like an assembly line. For decades, designing the world required armies of people hunched over tables, manually dragging pencils across paper to draft schematics. When early digital tools arrived, they didn't eliminate the manual labor, they digitized it. The pencil became a mouse, and the paper became a screen, locking the engineer into a rigid, point-and-click workflow. Putting these tasks on computers didn't automate the process of engineering. It turned highly trained problem solvers into manual operators of isolated software interfaces. Today, a standard design pipeline is completely fragmented. To get anything done, an engineer has to manually translate raw data across a half-dozen completely disconnected software ecosystems. To run a single structural test, you open CAD to create the geometry, you export that mesh into a simulation tool, run the analysis, write the report, and then manually update the BIM model. Legacy software companies recognized this friction early on and built multi-billion-dollar empires by acting as the toll booth. They owned the specific interface, which meant they owned the customer. The hours lost to manual tool operation now outweigh the time spent on actual design. When an engineer spends more time clicking through menus than solving problems, the software interface itself becomes the primary bottleneck. Breaking this bottleneck requires a different architecture entirely: Agentic AI. Agentic AI functions as an autonomous workflow orchestrator, executing complex, multi-step sequences across multiple platforms to achieve a specific goal. It bypasses the traditional UI. Instead of a human operating 5 different tools, human intent flows directly into a central AI agent, which handles the operation and generates the output. Consider a high-stakes predictive problem, mapping out the precise destruction zone of a 50-year flood. Historically, predicting water movement across physical terrain requires massive computation and observation, tethering an entire university lab to the problem. Solving this scale of fluid dynamics forced teams to spend weeks manually operating distinct software suites just for a baseline model. In an agentic workflow, that physical labor collapses into a single action. An engineer types one plain language prompt defining the goal: create a 50-year flood risk model using satellite data. The AI agent intercepts the request and acts as the central conductor. It pulls satellite imagery and triggers a GIS application to build a terrain model. The agent passes this to a meshing engine for a 3D grid, instantly running hydrology simulations. CAD, GIS, and simulation software are not disappearing. They have simply been demoted. They are no longer the primary user interfaces. They are invisible, background solver engines running powerfully beneath the surface. This structural shift poses an immediate financial threat to legacy software monopolies. Because the AI handles the complex integration, a startup or a university can bypass expensive proprietary ecosystems completely. The agent can seamlessly stitch together free, open-source tools to execute the exact same workflow. The economic power in the engineering sector is actively migrating. The value no longer sits with the creators of isolated drafting tools. It belongs to the builders of the AI orchestration platforms. Moving forward, the market will refuse to pay a premium just for the privilege of accessing a complex interface. Clients will only pay for automated, verifiable outcomes. This transition does not replace the human engineer. It actually elevates them. The professional identity of the engineer is changing from a manual operator of digital tools into a strategic supervisor of autonomous systems. Freed from the friction of the UI, a single supervising engineer can achieve massive scale, instantly directing agents to generate a living digital twin of complex civil infrastructure, integrating drone photogrammetry, asset databases, and crowd simulations all at once. The future of engineering is not found on a software screen. It is an autonomous workflow.